Hello there. Hope you are doing well. So here we have one of the text, and the text gives us the direction. So the direction points out here. There is a passage below, which is accompanied by a set of questions. We need to choose the best answer to each question. Well, uh, so without further ado, let's dive into the world of reading. Hello there. Welcome to Hello everyone. Hope you are doing well. Welcome to this online video discussion on mastering reading comprehension questions. So here we have a text, and we are going to deal the text. The text below is accompanied by a set of questions. We need to choose the best answer to each question. Previous to that, let me discuss this particular text. What this text is trying to give us the idea. The text is stated about here is a primer on how to think of the fundamental component of matter, right? A molecule is a stable collection of nuclei and electrons. If the collection contains a single nucleus, it is called an atom. Electrons are elementary particles with no internal structure and a negative electric charge. I hope you have read this text, and I presume that you must understood it. Yet I would like to give a more idea onto it. So what does the text actually provide? The text provides nothing but a primer on the fundamental components of matter, starting with molecules as stable collection, right? So then after it is trying to talk about more and stated about how it is a stable collection of nuclear and electron at the atomic level. A molecule with a single nucleus is called an atom. Then after, electrons are elementary particles with negative charge, while each nucleus consists of protons and neutrons. The interior of proton and neutrons is described as a complex space with quarks and gluons, isn't it? Then after, we also talk about uh, how particles with the same electric charge repel each other, and additional interaction involving quark and antiquark pairs called pions. So they are needed to bind protons and neutrons in the nucleus. The energy exchange in this process compensate for the electric, you can say that repulsion between, you can say that protons, and uh, therefore you can say that the short lifetime of pions limits the distance between protons and neutrons, um, confining the nucleus to a 1 of 10 femtometers radius, isn't it? So then after it tries to give more idea about it by stating that from a particle perspective, the nucleus is what? Um, mm, the nucleus is tiny compared to an atom. The text contrasts the size of a nitrogen nucleus with its atomic radius, while nuclei are heavy point-like positive charges without clear internal structure. Electrons are described as light. Then after, it is also stated that mm, uh, that it is stated about point-like negative charges. The text also notes that if matter were composed solely of point-like particles, atoms and molecules would be mostly empty space, isn't it? That's what it tries to point out. At the end of it, it is stated, however, if at the scale of atoms and molecules, quantum theory becomes relevant, right? Um, and it is stated that uh, It stated that the text explains that according to quantum theory, matter is described by continuous quantum clouds rather than being composed of localized particles in empty space, right? So the wave-like nature of matter predominates until a measurement disturbs it, challenging the idea of atoms and molecules as collection of point-like particles and emphasizing what the importance of quantum theory in understanding their behavior, isn't it? That's what the text gives us the idea. So if I look into the tone and the style, then what I can find out, the tone of the text is again informative, or you can say that scientific one, mm, and academic too, and academic, isn't it? Academic. So it maintains a neutral and objective tone. So if you talk about the tone, which is a neutral one, uh, and the main idea of the text is to provide a primer on the fundamental components of matter and going into the structure of atoms, molecules, and nuclei, isn't it? So these are the basic details of the text. Let's look into the question. What does the question point out? It asks us the question, which of the following is an assumption, right? Assumption about the behavior of matter at the atomic and molecule scale based on the passage. Now, if I look into all these four options, the first option say atoms and molecules are primarily described by classical physics. Then second, the location of particles at the atomic and molecular scale is always well defined. Third, matter behaves as localized particles in empty space until disturbed. Fourth, quantum theory is only applicable to extremely small particles. Right. Now, if I look into this particular passage, the passage explicitly states that what at the atomic and molecular scale, matter must be described by quantum theory, and the theory predicts that matter delocalizes into continuous quantum clouds until a measurement disturbs it. This concept of matter behaving as what? Continuous, uh, continuous, continuous quantum clouds. Quantum quantum clouds, right? Quantum clouds. Until disturbed, it's a significant assumption based on the passage of the means of the text, isn't it? So now look into the option one carefully. What do we find out? It is stated atoms and molecules are primarily described by classical physics. So if you talk about option one, which is uh, incorrect here, because the passage discusses the application of quantum theory at the atomic and molecular scale, which implies that atoms and molecules are not primarily described by classical physics. Classical physics, right? So it is not a correct assumption, cannot be taken. Option 2 stated that the location of particles at the atomic and molecular scale is always well defined. Now, this is also not true, as the passage states that matter doesn't have well defined position until a measurement disturbs it. So, it is not an assumption that the location of particle is always well defined. So, therefore, we can consider option 2 is eliminated. Option 3 point out what option 3 stated matter behaves as localized particles in empty space until disturbed. Now, this could be known as the correct answer. Why? Now, because the passage broadly states about what atomic and molecular scales. So, and it is also described by quantum theory. And the theory predicts that matter delocalizes, right? Matter behaves as localized. So, matter uh, delocalize into continuous quantum clouds until a measurement disturbs it. So, if you talk about that, if there is no disturbances, then matter behaves as localized. That is what the means assumption we can draw. So this concepts of matter behaving as continuous quantum clouds until disturbed is a significant assumption based on the passage. So we could consider option 3 brings that assumption. Option 4 stated that quantum theory is only applicable to extremely small particles, which is not correct here again. The passage does not state that quantum theory is only applicable to extremely small particles, right? It implies its applicability to atoms and molecules, but not exclusive to the small particles, right? So, hence, you could say the correct answer should be option 3. Hope you understood the idea.